Welcome to Retro Upgrade. Today we'll be making our own RGB cables. Here are a few examples. I have a few more. So these are probably the best output cables for retro consoles. There are a few exceptions. For the Dreamcast, for example, you can have VGA out, but RGB is usually outputted via SCART, at least in Europe. So this is for Mega Drive 2, I think. Yeah, it is. And this is the Super Nintendo one. These are all fake cables. This one is actually quite nice quality because the cable is quite thick. This is for the Dreamcast. This one is for the Mega Drive 2. The other one was for the Sega Saturn. This one. So you can see all of these have one thing in common. They are extremely thin. These are for my PlayStation 2 or 1, I think. I haven't used these yet, but I'm going to with the upscaler. So these feel extremely flimsy. This plastic is super cheap, not really something I would trust in a long run. The actual cable itself looks nice, but it ends in these very thin, flimsy things. So I would actually replace these. This is red, green, blue. Let's see, it's divided up, I'm guessing. Yeah. Okay. So red, green, and blue for YPVPR, and then audio. So these do work, but they sometimes introduce noise in the signal. That's because of poor shielding inside the cables, badly designed components inside. You need some extra components on some of the cables. For example, the Super Nintendo one needs a specific setup for PAL consoles and another one for NTSC consoles. And what ends up happening is that when you have the NTSC cables that you buy from AliExpress, they are almost always NTSC setup. So let me show you what I mean. Sorry for the shaky camera. I have the phone on one of the flimsy tripods. So you can see here there are no components at all here, but there are actually. Let's see, there is a resistor down there, right there. This one is one of the least grievous ones because it has a lot less components. But the more problematic ones was, for example, the Mega Drive 2 one that needs capacitors in series. Let's show you that one. This is a Mega Drive 2 one. I have fixed this on camera because it's the same output I used for the RGB converter for the ZX Spectrum I designed. So there are a few benefits of making your own cables. First of all, you get the quality you put in. So if you buy good quality cables, you get good quality connectors. Sorry, this is taking forever to unscrew. There we go. So as you can see here, okay, one of the wires broke. I can see that right now. I'll have to reattach this one. But otherwise, you can see there are capacitors and resistors and other stuff here. I'll resolder this one. There is a small resistor on the actual wire. It's a SMD resistor. I'll fix that later. That's fine for me. So, okay. So my idea is to use connectors like you can buy on AliExpress. I bought a few bags of stuff. So this is DIN 8, I think. Let's see. This is for the... I think this is for the Mega Drive 2. These are the mini DIN 9. These are meant to be built by you, so you can unscrew these. Open this up and solder your connections inside, so you can get the actual connector part out and solder your cables. Quite annoying to do, but it's the best way to actually ensure you have good quality stuff inside your connectors. I lost the screw, I think. But with this, you can actually make a pretty decent cable. That's the actual connector itself is good quality. Sorry for the focus issues. I think I dropped a screw or something. No, a locking ring that was inside. A metallic locking ring. I don't know really what it is for. I'll check the information sheet later. Let's look at the other stuff I got. These are the ones for the Mega Drive 1. A little bit thicker. This is a DIN 8, I think. 6, 7, 8, yeah. So these are also meant to be hooked up by anyone, actually. You can open them up, solder the wires, and then close them up and make a good connector from them. So let's see. You can see the solder points right there. So I have a few ideas on how to make a really good quality connector. But we'll start with making our own connectors and comparing them to the pre-built ones from AliExpress. I also got one last one. This is a little more tedious one. I bought 5 of these because these are more expensive. Oh, sorry, I hit the camera. So this is a Super Nintendo connector. So you have the inner part and then the outer shell. So these are also really nice. The quality seems fine. I have tried these before to make my own cables and they work. These are a little flimsy, so they are bendable connectors on the back. And you put it together like this. The wire comes in here and you just put this in the locking tab. It's upside down, I think. Anyway, with these and in combination with the last bag I got, these are SCART connectors in pieces. So they come in 3 pieces. Let's see if I can get them out. The sheet. You also have the screw part on the back. You bend this over. The inner part you can solder your connectors on right here. And then the shielding. So I put one together. It looks something like this. These look really nice. Quality is nice. Ignore the blue part, it's just a protective plastic. So you can take it off. I'm going to be using this and making my own Mega Drive 2 connector. So I can compare it to the Mega Drive 2. Because this one, I think, the Master System using this one actually had some really horrible noise, or it was this one. I can't really remember. So I'll check which one it is, and then I'll build a cable. Now, okay, so you're wondering because we're missing a part. So my idea is to use cheap HDMI cables as the core of the cable. Why? Okay, so these have shielded separated pairs inside. So every data signal has its own pair. So they are shielded. I can show on the screen right now how they look inside. We will be cutting these open. This wasn't very cheap because this is from the local Chinese shop because it's a 4K cable. Usually you want to go with the high quality stuff. This one is bought from AliExpress. This is a 8K cable. Can't really see that for the glare. It says 8K right there. This one showed a diagram of how the cable looked inside. Of course, the packaging doesn't really reflect the actual inside of the cable. Cable thickness is a little bit thin for my liking, but it uses the nice braided cover. The actual cable is quite stiff. Of course, it hurts to cut up these things, especially at €6 a pop. These are expensive, like I said. This cost me less than €2, so this should be fine. This is a meter cable, so it's not very long, but for what I need, it's about 2-meter cables should be fine for RGB signals. So let's get to it and start making our own cable. Okay, so this is the inside of a HDMI cable, a really high quality one. No, not really, but it's decent quality, enough. It can have extra shielding around these 3 wires. I'll explain why later. So this is ground, and the important part is that these right here are the data pairs and the clock signal. I think this is clock. So I was thinking of running red, green and blue through these wires and the dedicated grounds that are associated with them. Some consoles don't have dedicated grounds. That's fine. You just tie them all together and you should be fine, good to go. And also I was going to run the audio through the middle ones because the chances of that being shielded is higher. Okay, why would you want to do this? You get a better cable than you can buy from AliExpress, a really shielded one. You don't have any crosstalk in between the lines. You can put power and ground directly on one of the wires or the shielding, however you want. You can also add extra data lines if the console can send them. For example, the Super Nintendo needs a 16 or a 4:3 aspect ratio. You can actually send the signal through one of the wires with a resistor coupled to 5 volts, and then you can get 4:3 or 16:9. It has to go to a specific pin on the SCART connector for doing that. I'll explain all that later. It's a little bit complicated. Okay, so let's just take a quick look at the actual wire and why I chose this. Okay, so this is a collection of RGB cables for different systems. There are a lot more than these, but this is a good collection anyway. I leave the link in the description so you can check it out. Okay, so I'm going to make one for the master system or Mega Drive 1. It's the thick one, this one, because the one I have has a horizontal banding, no, vertical banding. So it has lines right across the entire screen. So that's usually the sync signal leaking into the RGB signal. So you can see the sync pulses in the actual image. Okay, so let's see. So these are actually a bit more complex than the other ones. You can see all of them are different. Some have nothing on the lines, some have some. These are the settings thing I told you about for 4:3, 16:9. So these 2 pins are responsible for that on the TV. You can also change it directly on the TV, but this does it automatically, so why not? Okay, so if you check these 2 cables, they're pretty similar. For this is the mini DIN 9 and this is the DIN 8 connector. So these are for the Mega Drive 2 or the Sega Master System 2 as well. Sega Master System 1 and the Mega Drive 1 have this connector. So we're going for this. So we will have to incorporate a 75 ohm resistor in series with a 220 UF capacitor, and that's for the red, green and blue line. Also, I am passing through 5 volts from the console. You have the 5 volt line right there, and I am setting this up for 4x3 because the Mega Drive or Master System is 4x3. You can actually leave it without and just set it up with your TV. Okay, so, and as sync, because normally sync is on green in some cases, but as sync you send over the composite video. You don't use it for displaying. You also choose one of these, I think it's this one, 8, that you can choose composite video is not enabled. You enable RGB. You also send over the ground. You see this one doesn't have dedicated grounds for red, green and blue, so this one is one that's tied together to all of them. You can see all the grounds here, 21, 18, 13, 9. So all of the red, green and blues actually have dedicated ground pins on the SCART connector, but it's not used by most consoles. So we'll go with the normal setup. We'll build this. We use the okay, so this is for the Mini D9. This is for the Mega Drive 2 and also the Master System 2. They both use the same connector, and this is also useful for my RGB converter for the ZX Spectrum I designed. I used this one, and 9 pin. So 10 connectors is €7, so it's not too bad. Of course, if you just want to make a one-off, it's kind of expensive because you need to buy the SCART end and the HDMI cable, but you still will be under the price of a commercial good quality RGB cable. They usually run you between 25 and €40. So yeah, OC Games €30 plus shipping, so it's about 35. 65 for this one, also a good quality one. 450, but that's from AliExpress. These are the ones that you want to be careful with because they don't come correctly set up. But high quality cables are expensive, really expensive, so especially if you're buying them from a reputable source like these. That's €55 for a cable. That's extremely expensive, and you don't get that much benefit. You get the benefit of not having banding and stuff, but you can do it by yourself. I'll show you all the costs together. Here are the Super Nintendo connectors, are quite expensive. They cost $150 each for each set of connectors, which is a little bit of a pain, but wait, what can you do? And then you have also, and also these are the mini, or these are the DIN 8s I bought. Let's see if I can find 8 pin right there. So I bought these, $6 for 10. So these are inexpensive. The expensive part was actually the SCART cables themselves right here. So 10 SCART cables. Okay, so they went down in price. Of course they did. I ordered 10 at 78. Oh no, so they are not that expensive. So the entire set is 78 cents for one set. So not too bad actually, and this is new. They didn't have the Super Nintendo connectors last time I checked, but these are quite nicely built, good quality. 78 cents for that. Let's go for the DIN 8. We pay €6 for 10, so it's about 60 cents. 60 cents, and then the USB cable, that was €3. You end up with a grand total of 438. So it's really cheap. It's of course it's labor. It takes you time to do this. This is fiddly work, especially soldering the wires inside here. And also you need the small components inside in some cases. Like in this case, we need 75 ohm resistors. They are super cheap, and 220 UF capacitors, they are also cheap, and you need one 180 resistor as well. So these can be SMD, or they can be through-hole components. Through-hole components are a lot easier to solder. I am thinking of a project where I make a few things that will help people make their own cables and actually just use one high-quality cable to connect all of their consoles. I'll go into detail in a little while. Okay, so that's really cheap for a good cable, because AliExpress, let's see, Mega Drive RGB, they're like 378, and these are actually really bad. €4, €6. This is the correct one for Mega Drive 1. This is the thick one. So actually it's cheaper to make your own, even buying the cable and stuff. And look at how thin the cable is. So, and from experience, I will show you there is a actual banding issue with these. I bought one, I have one here, so I'll show you the actual problem. And the problem is actually enhanced even further when you upscale the image to 1080p, because you see the banding even clearer. Okay, we're back at the bench. We'll need a few supplies to make our own cables. You will need the parts, obviously, the actual connectors, the cable. I'll be using this one because it's the more expensive one. Hopefully it's a better quality one. You will also need some solder wire or solder flux, very recommended. This is a little bit dirty, but it works. Soldering iron, obviously, otherwise you can't solder the wires. And some patience, and also if you want to cut the cable up. Okay, so I'm actually going to design a special connection system for this, so we don't need to cut up the HDMI cables. So I will make two ends. I will make a SCART connector with a sync stripper. I'll explain how that works in a second, and a HDMI connector here. And I'll make ends for all the other consoles with the electronics they need inside the ends. So you connect this to the console, it will have a HDMI output or input. So you connect the cable in between. So you just need one cable of good quality. Then you can connect all your consoles with this. So you will probably need just one of these, and then multiple of these depending on the consoles you have. So that was a product idea I had a while ago. I'm still thinking of doing it because I can make all the electronics inside this. So this is universal. Okay, so let me explain what the sync stripper is. It's a small chip. It's a LM1881. So it takes the composite video and strips out the sync signal from it, so it's not noisy anymore. Unfortunately, it bumps it up to 5 volts, so it's a high signal. But you can actually put a resistor in series and then drag it down again to what the SCART expects. It's about a volt or so. So that's good. I do have a few chips with sync strippers on. Okay, so these are both LM1881 that are sync strippers. These are through-hole versions, dip package, and these are SMD versions of the same thing. So these require 5 volts, composite video input, and you get a few outputs. But the most important one for us is this actual sync signal. So I was going to build this into this and put it on a switch, so you can actually choose if you want it or not. Some consoles don't like sync strippers, so you turn it off, obviously. But that gives you the option to get a cleaner sync signal with my system I'm going to design later. I'm going to make it a series. I'm going to design one connector for each episode for this, and I will make a dedicated episode for this also, outlining the actual entire project. So I'll start with the SCART end and then go and do one for each console. I just have to decide on how I'm going to mount the connectors onto the PCBs I'm going to design, because it can get quite tedious to solder wires that are going up from the PCB and then building an enclosure to hold everything together so this doesn't pop out, for example. But I have a few ideas. So if you take off the actual shielding here from one side, this is actually quite simple. So I can probably, if I can get the pins, I can get this thick of a pin, can actually design my own, I think. I'm not sure yet, but yeah, that's the idea at least. Feels decent. It has covers for the HDMI. Unfortunately, this is going to die. I bought it for the sole purpose of actually destroying it, so don't cringe too much. It will end up in a better place, which is my collection of video games, and would be used quite a lot more than if it was a HDMI. There we go. So this is a normal HDMI cable, okay? So let's cut this right through. And let's see if we can see all the actual layers. So it's kind of hard to see, but there are individual grounding around all of these. Let's see if I can take off some of the sheeting. Okay, so do you see these right there? These have two connectors inside. Let's see if I can get it in focus. And a wire and a ground, pretty much. You can see them right there. Okay, so it has some nice connector holders. You can see the little U shape. You can put in the wire and let it hang out from there, and then fill it with solder. There are 3 wires inside this. This is D plus, D minus, the white one, this one right here, and this is ground. So you can see sheeting goes back when you heat it up. There we go. We will not be using the actual ground because this will be ground. I could put them together, I guess. Now for a word from our sponsor, PCBWay. They have sponsored the channel a while now, and I'm really happy they did, because that means I can continue making videos. They have amazing deals on their website. Go visit them. You can go from, for example, like my projects here, you can make them a reality. This is the SCART connector I was talking about. I also made this. This is one of my own designs, and I have the real thing at home, and it's a really nice feeling. Go test it out at pcbway.com. So put it on the positive side. Better? Yeah, a lot better. Okay. Don't be like me, don't forget the thingy to screw on at the end, and you have to desolder everything. Okay, let's get to testing. Looks decent enough. The heating went down here, so you can glue this with a dab of super glue and then it stays. Not important though. Okay, we're back. We have the master system up. I have the right power jack, and here is the cable I'm actually using for the master system. It has an external audio plug for the Mega Drive, so I get stereo out from, because this plug doesn't support stereo otherwise. But that doesn't matter right now. I'm going to plug this into my upscaler, the GBSC. I will then plug in the power, not right now though. The actual GBSC is connected to my capture card. You see it on the top right corner here. I don't think we'll get audio because I have the external audio hooked up only. I don't have the internal one. That doesn't matter. Actually, that would actually improve noise if you route the audio outside, because audio can actually mix in with the video signal. Okay, so I'll just split this off because I can't hook up the audio anyway. So as you can see, very thin, very flimsy. I have opened up the SCART connector, and it's poor quality as well inside. I had actually to put in the resistors and capacitors myself because they weren't there. And this was like €7, I think. Okay, let's see if I can get this in. There we go. Power. I have a game, Dracula, Bram Stoker's Dracula. It's a really crappy game, but it's our original blue label, so it's collectible at least. There we go. Let's turn on the capture card. DMI. Oh yeah, there we go. Master system. The colors are off. There we go. The colors are okay. Okay, so you can see the jail bars. Let's zoom in to the actual picture from the capture card. So you can't really see the jail barring on the screen right now. You will see it on very light colored stuff. You can actually see it right now. When the picture stands still, you can see bars of different colors. Now the colors turn fine, so seems, yeah, okay, I have a bad connection. You can see the gel bars right here. See the gray lines on everything? That are gel, those are gel bars. Yeah, and they're annoying to deal with because they're really hard to get rid of because it's dependent on the cable. Okay, so we're back here again. Now you can see the jail barring on the purple stuff. When I'm jumping, okay, it's not shimmering as much as before. There was some kind of skeleton. Okay, so let's put in my new cable, see if it works first of all, and hopefully it looks better. So you can see there's no trickery. Here's my cable. Let's try to push this in. This is going to be a tight fit the first time. It always is. Vaseline. Oh boy. One of the pins is not really aligned, so I guess I'll force it and align it that way. There we go. It's in. Okay, perfect. Let's see. Let's turn this on. Took a while for the other one to get sync, so hopefully this works. Yeah, and a better picture actually. No gel barring whatsoever. Let's see if that's true for the white picture. Yeah, no, there's still some gel barring, but not as bad. Let's restart. There we go. So there is some slight gel barring, but not even close to what it was before because you could see the gray lines. And it's not that bad anymore. Can still see them. There are some limitations of the console actually, but that is not too bad. And these cables cost me €4 to make. The ones that I showed you, I had to modify, and they cost me like €8 or €9. So I'll be making the prototype for the SCART HDMI converter thingy. So I'm going to use a SCART cable as the interface for two connectors, and then you don't need to solder cables or anything. I'm trying to start the game. Okay, so there is some slight gel barring, but it's not as bad. Shimmering is gone too. Oh no, this works. I can play this. Perfect. Okay, so that will be all. I'll put some comparison pictures to show the before and after. This wouldn't be amazing because the HDMI cable wasn't absolute best quality either, and the noise can come from the actual console as well. Okay, that's everything for today. Have a nice one. Bye.